All right, so let's bring up this presentation. Okay, so again, the question was how to estimate the number of blocks your stake pool will make. So let's go through. We're not going to use any kind of fancy formulas. We're just going to reason it out by thought and just thinking. So this should be, it doesn't matter if you've taken, a lot of uh, fancy math courses. You don't need to worry about any of that. This should just make sense from just the standpoint of reasoning it out logically. So let's go through it. There's some information that we need to get started out. So obviously, an epoch in Cardano is 5 days long, and in each epoch there's 432,000 slots with one slot every second. So essentially that's saying that there's 432,000 seconds in 5 days. And if you calculate that out, you'll find that's correct. One slot per second. Now there's this thing called the active slot coefficient, and it's set to 5%, or that there's 0.05 blocks per slot. And so essentially what you have to do, what this means is that the stake pools and the BFT nodes that IOG is running are not producing a block every slot. It would have to be producing a block every second. Well, no, that's not the case. There are less blocks produced than there are slots, and that is determined by this active slot coefficient. So only 5% of the slots have blocks in them. And so if you calculate that out, that's 5% times 432,000. It turns out that there are 21,600 blocks in an epoch. Now, obviously, if they change this coefficient, this number will change, but under the current parameters of the blockchain, the number of blocks in an epoch total is 21,600. However, okay, because we're early on in the Shelley process, remember that there is this decentralization parameter. Now you can find out what this decentralization parameter is by looking into Daedalus. So if I pop up Daedalus and you go to the delegation center, which is right here, and then you're at the info tab, it tells you exactly what the D parameter is. It says currently 20% of the blocks are produced by stake pools. So if it's saying 20%, then 80% of them are produced by the IOG BFT nodes, the old Byron era nodes. And therefore, what that means, I'm going to close that out. Therefore, what that means is that the D, the decentralization parameter, is 0.8. 80% are made by the old Byron era nodes, 20% are made by the stake pools. So stake pools, because the amount produced by the BFT nodes plus the amount produced by the stake pools has to equal 1. That's the totality of the blocks. So stake pools make 20%. So if we take 20%, multiply it by 21,600, we're left with 4,320 blocks. So what that's saying is that in epoch 212, there are 4,320 opportunities for a pool to mint a block. Okay, so that gives us the number of blocks that the stake pools, the total number of blocks that the stake pools will produce during this particular epoch. Now we have that number. That's an important number that we need to know. Now we can ask really the question that we want to get to. We want to know the probability of the pool producing at least one block, or you could say, what is the probability of the stake pool producing at least one block at some point during the epoch? Okay, well, so now we get into how to solve that question. So one way to look at the problem is to say that the pool can either produce 0 blocks or it can produce, well, basically not 0 blocks or greater than 0 blocks. So one way to write that is, I'm going to use P here to denote the probability. So the probability of producing 0 blocks plus the probability of producing not 0 blocks, or basically greater than 0 blocks. So I'm just going to use this bar over the top to indicate not 0. That has to equal 1, 1 being the totality of all the blocks produced. So there's only two options. Either the pool will produce no blocks, there will be total failure to produce any block, or it will produce at least one block. So those two probabilities have to add up to 1, and therefore the probability of producing at least one block is equal to 1 minus the probability of producing 0 blocks. Now, why am I using this over here? Well, because the probability of the pool to make exactly 0 blocks is much simpler to calculate than calculating the probability of it not producing 0. I don't want to have to go through and calculate the probability that it'll make 1, the probability that it'll make 2, the probability that it'll make 3, and add all of those up. What I want to do is I just want to be able to calculate what's the probability that it's going to produce at least 1. And so all I really need to know is I need to calculate one thing, the probability that it will produce exactly 0, and then the probability that it won't do that is what I'm interested in. So we will calculate the probability the pool will make 0 blocks. Well, that's going to make this a somewhat morbid exercise because we're going to try to calculate the chances of total abject failure of the stake pool. So if we get started on that, there are 4,320 opportunities to fail at producing a block. Why is that? Well, because the stake pools will produce 4,320 blocks this epoch. And so we could ask, what are the odds of not making a block for or at each opportunity? So in each one of the slots where these 4,320 stake pool produced blocks will be found, what are the odds? What are the chances? What are the probabilities that the pool, your particular pool, will fail to produce a block? Okay, so there's some more information that we need in order to answer this particular question. We need to know the total active stake for epoch 212. And the answer to that is it's 12.10 billion ADA. So this is how much ADA was staked at the time that the stake snapshot that's now active in epoch 212 was collected. All right, so you could say there's like a lottery for which stake pools can produce a block, and each ADA of stake that they have is one ticket in that lottery, and there's 12.10 billion different tickets. And so the more tickets that you have, the more active stake that you have in your pool, the more opportunities, the more chances that they will win a slot leadership position at that particular slot when a block is going to be produced. So that's essentially how we calculate the probabilities. The probability, okay, so we're going to calculate this like using the same amount of stake just as a test case here as we used when using the tool that we have on our website to do this. So 10 million ADA. So we're going to imagine that there is a stake pool whose active stake during this epoch is 10 million ADA. So I'll just rewrite that as 1 times 10 to the 7th ADA, where the total active stake is 1.21 times 10 to the 10 ADA. So that's 12 billion. This is 10 million. So the probability of success, P of S, where S is success, probability of success in producing a block is going to be the amount of active stake in the pool, so that's 10 million, divided by the total active stake on the network, 12.1 billion. And if you do that calculation, you come up with this number, 0.826 times 10 to the minus 3. So what is that saying in terms of percentages? There's a less than 1% chance. There's a 0.8% chance of success at any particular, in each one of these 4,320 opportunities. In each one of these 4,320 opportunities, the chance of success of your pool producing a block is 0.8%, a little bit higher, 0.82%. Okay, what is the probability of failure? Because remember, what we're going to do is we're going to calculate the probability that the pool fails at each opportunity, 4,320 of them. So that what we really need is the probability of failure. And so that's just 1 minus the probability of success. Because again, there's only two options here. It will either fail, in that particular slot, it will either fail to produce a block or it will successfully produce a block. So therefore, probability of failure is just 1 minus the probability of success. Of course, 1 representing 100%. So therefore, the probability of failure calculates out to be 99.92% chance of failure. Okay, so in each one of these 4,320 opportunities, the chances of failure are quite high, 99.92%. Now, if I were a betting person, I would certainly not take this wager, okay, because it's very likely that you're going to lose. However, let's just forge on with the calculation and see what happens after we look at each of these particular opportunities, all 4,000 of them. So remember, again, that we're calculating this for a pool with 10 million active stake. If you're following along with this and you have the active stake for the pool that you're interested in, just go ahead and substitute in this value of 10 million in all of the places where we're doing this calculation. Okay, so I'll move on here. Again, we haven't used any kind of fancy formulas now. This is all just reasoning it out with a, kind of like a thought experiment. So now we can go ahead and we can start answering this question. So here I have probability of 0. Remember, that's the probability that the pool will completely fail to produce any block in each one of the opportunities, the 4,320 opportunities that there will be to produce a block in Epoch 212. So what is that probability? Well, so that's just what we can do is we can start enumerating out what the probability is in each one of those particular block locations. So when the first block is produced, the odds, the probability that the pool will fail is 99.92%. Now, we have to, what we're interested in is seeing that the pool will fail every time. So it has to fail this time, and through all of the times out to 4,320 times. In order to get that probability, we have to multiply together the probability of failure at each individual particular case. So in the slot where block 1 will be produced, the probability of failure is 99.92%. And then we have to multiply that by the probability of failure for the slot in which block 2 will be made. And then you follow that with the probability of failure in the slot where block 3 will be made. And you multiply that out, and it turns out you're going to multiply this number together 4,320 times. So the shorthand way to write that is that the probability of total failure, your pool producing no blocks, is going to be 99.92% to the power 4,320. Now, no sane person is going to want to try to calculate that by hand. That's why we have computers, thank goodness. And so if you calculate this out, if you get the computer to calculate this out, you will end up with 0.0281. And in other words, the answer to this, the probability of total failure is 2.811% chance of total failure. So coming back now to what we were talking about earlier, the probability of the pool producing not 0 blocks, or at least 1 block, is going to be 1 minus the probability of complete failure. So that is 1 minus 0.02811. So the probability of producing at least 1 block is therefore 97.19%. Now, certainly when I calculated this out the first time, it made me stop and I wanted to go back through and check everything because, it's kind of a surprising answer to see that the odds or the probability that this pool with 10 million stake in it has a better than a 97% chance of producing at least one block during this epoch. Especially that's surprising when you come back up here and you remember, all right, that the odds for any one particular chance of it to make a block, the chance of it to fail is 99.92%. It's almost a certain failure. But after you repeat this process 4,320 times, the chance of success is almost as high as the cumulative chance of success is almost as high as the chance of any individual failure. And so it's a little bit of it creates a little bit of cognitive dissonance there, but the maths bear this out. 99.92% chance of failure at any single opportunity. But after you do that 4,320 times, the chance that you're going to not fail in one of those particular opportunities is better than 97%. So, there's also a lesson here as I've been thinking about this. And certainly there's an important lesson for any kind of engineer that's working on building something that, like in any kind of civil engineering project or mechanical engineering type of thing where, people are going to be using it. If you make something, and now let's just imagine, okay, that this 99.92% is not the chance of failure as we're imagining it here for a stake pool, but let's imagine that, you've produced some sort of machine, and the machine's chances of success, rather, are 99.92%. Well, if someone told me that, the machine will succeed 99.92% of the time, I would be quite happy, right? I would say, there's not really that much to worry about. But if you just repeat that action of whatever that machine is doing 4,320 times, the chance that that machine would fail, okay, in this particular case, the chance that it would succeed, because we just kind of flip this around. It has a 99.92% chance of success at any one particular moment that it's being operated. But if we operate it 4,320 times, its chance of success in all of those cases comes down to only 2.8%. Well, if you told me that the chance of something being successful was only 2.8%, I would not use it. Okay, so the repetition or the reuse of the thing so many times, even though the individual chance of success is very high, the cumulative chance of success is virtually almost impossible. 2.8% is very low. So the story is, if you're making something, and even if you certify its reliability at higher than 99%, you need to do better than that, because it only takes about 4,320 times, and somewhere in there's a pretty high chance of that machine failing. So just imagine something like, we have this era now of reusable rockets. Right? Just think of how many different operations are going on in the machinery of that rocket, and then you reuse it and you expect that thing to work over and over and over again. And who knows? Maybe there's some part in there that is doing some operation many, many, many times, unless it's known that that thing is going to work at much, much higher than 99.92%, because after relatively few opportunities, the thing has a pretty high chance of failure. So anyway, that just kind of jumped out at me. I'm sorry for that sidetrack, but I thought that was just very interesting. So the answer here is that by doing this, we've calculated, and it's a pretty simple calculation. It's not very difficult to get to this. The probability that you will produce at least one block is 97.19%, and you can go through this calculation with any of the active stakes for the various pools and find out.